Today we're here for an asteroid called 2012 DA14. Hello everyone, I'm Gay Hill. Now DA14 is not a threat. It will not hit the Earth. Scientists say the closest it will get will be about 17,200 miles away from the surface. It'll reach the point, its closest point, about 25 minutes now. It's what we call closest approach, but actually closest approach takes hours as it comes in towards the planet. And from that point on, it'll be flying away from the planet. We can't see the asteroid here in the United States because it's daytime here, but observers in the eastern hemisphere, where it's dark, can. And we reached out to amateur astronomers and observatories out there on the other side of the world, and they have been kind enough to share their pictures. Let's take a look at some of them. The first one we're going to go to is from the Bateman Observatory, and you see there on the right of your screen, right there, is DA14. It's tracking upwards. Now, Bateman is near, I believe, the southeastern part of Australia. It's operated by a hobbyist. His name is David Harold, and he is a retiree who actually is very interested in this and has become a bit of an expert. The second one is in Sanford Valley. It's called the Sanford Valley Observatory. It's outside of Brisbane. And here you see it on his telescope tracking down. And the person who operates this, again, a hobbyist, his name is Jonathan Bradshaw. And he has his telescope right by his house, he tells us. And there you see that one. The telescope that we will be relying most on is called the Gingen Observatory, and it is near the area, the town of Perth. It's about an hour out of Perth, and it is on the western side, and there you see it. This is actually a live image from Gingen right now. It's just an hour north of Perth, and we will be talking to the folks there. Now, the person operating the telescope right now is Rick Tonello. Paul Woods is also there. He's their IT guy. And later on, in just a few moments, we'll be speaking to Ariel Heery. She is the part-time astronomer, and she also happens to be a primary school teacher. And all of these people have been extremely helpful today. Now, let's talk a little bit about the Jet Propulsion Lab's Near-Earth Objects program. The goal is to find the large asteroids and comets that have any potential of hitting Earth. Don Yeomans is the manager of the NEO office, and he gives us now this DA14 reality check.
Asteroid 2012 DA14 is an object about half the size of a football field in diameter that is going to pass very close to the Earth on February 15th. Coming from the south to the north, it actually gets to within 17,200 miles of the Earth's surface and will pass interior to the geosynchronous satellites and the GPS satellites. But there's really no chance of the asteroid hitting the Earth, and very little chance it will hit a satellite. Although this object gets very close to the Earth on February 15th, it's fairly small as asteroids go, and it won't be observable with a naked eye, but if you happen to be located in Eastern Europe, Asia, Australia, and you know where to look, and you have a pair of binoculars, it will indeed be visible. The asteroid was discovered by a group of Spanish astronomers in La Sagra Observatory in southern Spain. An object the size of DA14 actually impacted the Earth on June 30th, 1908, the so-called Tunguska event. An object of about 30 or 40 meters came down into the Earth's atmosphere and exploded, leveling trees for 820 square miles. The close approach of this object 2012 DA14 on February 15th is nothing to worry about. Its orbit is very well known. We know exactly where it's going to go, and it cannot hit the Earth. 20 years ago, we probably wouldn't have found this object, but now NASA's observing the skies nightly and picking up these objects, and we track them for 100 years into the future and see if any of them make interesting close Earth approaches, not only because of the threat issue, but because these objects are important for science, they're important for future resources, as well as threats.
Well, right now I am joined by Paul Chodas. He's a scientist in NASA's Near-Earth Objects Office. And Paul, we probably have to address right off the top this meteor that hit Russia overnight.
What an exciting day. We feel like it's like in a shooting gallery here. We have two rare events of near-Earth objects approaching the Earth on the same day.
What can you tell us about this? Anything at this point?
First of all, the two events are unrelated. The meteor over Siberia and over Russia was not related to the asteroid 2012 DA, which we are still tracking. You have a live shot of it. And they're not in the same trajectory, the same orbit. It's simply a coincidence that they happen to hit and come near the Earth at the same day.
How big was this meteor?
The meteor, we think, was around 15 meters in size, which is about 1/3 the size of DA14 itself.
Okay, so it's much smaller.
Much smaller, and you can see what sort of destruction and shock wave that a smaller asteroid can produce. It's like Mother Nature is showing us what a small one, a tiny one, really can do. And DA14 is really only a small asteroid on that scale.
So, making it clear again, these two are not related.
Not related, right.
At all. So let's talk about the Near-Earth Objects Office. How do you find asteroids and comets? How do you track them?
Finding asteroids and tracking them is a worldwide effort, and NASA is the lead agency that coordinates the efforts. Around the world, I think we have an example. The images taken by observatories really are showing the position of each of the asteroid against a star background. The astronomers report the positions, like latitude, longitude, only it's on the sky, report the positions to the Minor Planet Center, another NASA-funded facility in Cambridge, Massachusetts, which serves as a clearinghouse for all observatories around the world. Then we take the data from them. They help us by computing a preliminary orbit. We take that data and compute a very precise orbit and then analyze the possible impact probabilities into the future. We go 100 years into the future, and we're analyzing the future motion of these objects.
So DA14 was spotted by an observatory in Spain.
Yes, it was an amateur group, a very sophisticated amateur group. That's the red dot there showing where their observatory is. And they have state-of-the-art equipment to find these things. NASA also has many surveys, and I might add that NASA-funded surveys have found about 95% of the near-Earth objects. You see the blue dots here indicating the major NASA observatories. There's also another one, a survey telescope in Maui.
Well, let's look at our asteroid right now on the Jinjin Observatory shot. Can we cut to that right now? You can see it right there. Can you describe to us, you see the streaking. Is this a movement of the telescope at this point? Is that?
Well, first of all, it's just amazing how bright the asteroid is coming. A little guy like this, only 45 meters in diameter, 150 feet, half the size of a football field, and yet it's now accessible to many telescopes around the world of only moderate size. The reason it's streaked, first of all, you can see how fast it's moving, and the reason it streaks is that there are little time exposures taken of it, and it actually moves during the time exposure.
Well, we have Ariel Hiri, who's at the observatory right now. She is on the phone. Ariel, are you there?
I am.
Hi, Ariel. Ariel, we chatted a little bit earlier. Are people excited over there?
Very much so. There's a lot of interest in it. Rick on his own's done, I think, in the last probably half hour, about 5 interviews for different things. We've had newspapers, schools, it's big in the schools. We had the public in today, earlier on this evening, and we did a talk on it then. So it's very big over here.
So can you describe to us what you're seeing? Clear skies, I guess, because we see a very good image.
Very clear skies. It's an amazingly fantastic night. The Milky Way is so clear you could almost touch it. And the weather is perfect. It's about 22 degrees at the moment. So it's a very, very good evening for doing what we're doing at the moment.
So it is about 3 o'clock in the morning there, and how long will you be watching it today?
Yeah, it's about 3 o'clock in the morning here, and Rick picked up the asteroid about 1:30, and we've not taken our eyes off the screen ever since. And Rick hasn't moved from his spot because we don't want to lose it.
Oh, no.
Can you see it in a small telescope? Can you see it in binoculars? It seems to be amazingly bright
Yes,
for such a
we
small
can
object.
see it with binoculars. You can see it in a small telescope. Grant, who's another astronomer here, has actually attached his camera to one of the telescopes, and he's taking a lot of images that he's going to put together in a slow-mo at the end of it. And we've got another telescope up as well that you could see it in.
So we have viewers all over the world, but in your neck of the woods, what part of the sky are you looking at?
We are looking at, Rick, which part of the sky are we looking at right now?
I imagine this thing is moving so fast that you have to look it up on the table
Crater.
to find out where you are right now. It's moving so quickly.
So it's...
It is. We've just looked up, and it's in the crater area.
Crater, the constellation crater.
Okay. All right.
Yeah.
Well, Ariel, thank you so much. We will be coming back to your shot throughout the program, and thank you for bringing it to us. Have a great day out there.
You're welcome. Thank you
All
very
right.
much.
All right, so that is Ariel Harry, and she is at the Gingin Observatory, and they are the folks that are bringing us the shot, this best shot that we can get. And again, so much of this is dependent upon observers who are hobbyists, and Ariel is a part-time astronomer, and she's a school teacher. That's her day job. So let's take a look at where we are right now. The asteroid is about 17,500 miles away, 515 miles away. Closest approach, it appears to be closer to 25 minutes past the hour. And the visualization you see right there, that's computer simulation, is something that we've developed here at JPL. It's a visualization tool we've been cutting to throughout today. It's called Eyes on the Solar System, and the tool uses data on DA14 and allows us to track it in near real time. And Kevin Hussey is the manager of the visualization technology, and he is here to demonstrate how you at home can use it and follow along. Kevin?
Thank you, Gay. I am going to show you how you can, by going to this website, do everything I'm going to show you and recreate the simulation that you saw on the screen. So what appears to be a view of the solar system from above, looks like a textbook drawing, is actually models of the solar system and trajectories of our spacecraft and planets inside of a game engine. You can use your mouse, and I'm now going to click and drag my mouse, and you can see that I'm changing the position of the camera so it looks like I'm flying about our solar system. Anything that has a label is clickable. So before we get to DA14, I have a minute here. I'm going to take you out to Saturn, and we're going to look for another one of our missions that's currently active. There's the Cassini mission. Again, if you click on a label, we will take you to that spacecraft, and if you were at Cassini, this is how Saturn would appear to you at this time. All right, I'm going to take us back home, which would be the center of the solar system, and now I'm going to recreate that view that we showed you earlier. The Earth's label is obstructed by a DA14's label, so I'm going to double click on DA14 and take you into a view of the asteroid. When you double click on a label, we put a camera at the center and we allow you to move about. So right now we have what we call shadow lighting. It's semi-natural. I'm going to go ahead, I'm going to change the lighting model to a full-blown movie light. There it is, a floodlight if you will. I'm going to go ahead, I'm going to turn off the trajectories of the trails of the spacecraft, and I'm going to turn off the labels. We're getting closer. And then what I'm going to do is, there's a button here we've added that says Ride Along. So if you click the Ride Along button, you'll put the asteroid at the bottom of the screen. I call this the Bruce Willis view, and we can zoom in a bit. I'm going to go to 47 degrees, and you will be able to see this as you would if you were riding along with the asteroid. So with that, I would say that, remember, you can do exactly what I'm doing by visiting that website, and I encourage you to explore not only DA14 It's on its closest approach, but other objects and planets that are in our solar system. Gay?
All right. Thanks, Kevin. Well, we've been seeing and hearing from observers using optical telescopes around the world, but DA14 will also be studied by radar astronomers as well. And not far from here in California's Mojave Desert is the Goldstone Station for NASA's Deep Space Network. JPL's Lance Benner is a radar scientist, and he will be heading out there in just a couple of hours to observe this. Tell us a little bit about what you'll be doing at Goldstone.
Well, we're going to be using the Goldstone Solar System radar to study the physical properties of 2012 DA14 by measuring its size, its shape, its rotation state, trying to understand its surface roughness, and we'll also be measuring its distance and velocity on multiple occasions over the course of the next several days in an attempt to improve our understanding of its orbit and enable us to compute its motion much farther into the future than we could otherwise.
Now, this is a radar telescope, so it operates differently than all of the telescopes we've been seeing. It sends out a ping, basically?
Well, in effect, I mean, a radar facility is an active form of observation where we transmit a radio beam at the asteroid, and then the radio signal, for example, imagine that this was the asteroid, and the signal goes up, hits the asteroid, bounces off of it, and then comes back down to the ground, and then we switch from transmitting to receiving, and we make what's effectively a time exposure, and we can get a radar image. And then as the asteroid rotates, we can build up a sequence of radar images over the course of its rotation, and then use that later on to estimate its three-dimensional shape and its spin state.
So this is Toutatis?
This is a scale model of an asteroid called Toutatis, which made a close approach to Earth about 2 months ago on December 12th. It's a much larger object than 2012 DA14. It's about 4.5 kilometers on its long axis, which is a little bit less than 3 miles, whereas 2012 DA14 we think is in the order of 40 to 50 meters, or about half the size of a football field.
We have footage of your data from this particular asteroid that we can show folks, and how you were able to glean some of this information from that.
Yeah, so this shows a sequence of radar images from December 12th that have been turned into an animation. They have a resolution of 4 meters per pixel vertically, and now we're seeing some from December 13th, around the time the asteroid made its closest approach. This is an example of what we can do with the Goldstone Solar System radar. We can get extraordinarily high-resolution images if the objects are close enough and big enough for us to see them like this. To give you a sense of what 4 meters really is, I'm about 1.8 meters tall, so the best resolution we can get with Goldstone is only about double my height.
But you're able to get so much more information.
On an object that's millions of kilometers away from us.
Okay.
So tonight's observations of 2012 DA14, it'll be extraordinarily bright for us, and we're again planning to get images with a resolution as fine as about 4 meters per pixel.
So walking away from this flyby, we will have so much more information than we had before. We'll know a little bit about perhaps its spin rate, its size.
Yeah, currently there's only limited information available, and the majority of it comes from unpublished work that was done by Nick Moskovitz at MIT last year, shortly after the asteroid's discovery. He found that it has a rocky silicate composition similar to the composition of many Earth-approaching asteroids, and also many meteorites that we find. It appears to rotate about once every 6 hours. And as it rotates, its brightness fluctuates considerably, and as a result, we think that it's quite elongated. But at this point, that's all we know, and so we'll find out more, we hope tonight, if things go well with the Goldstone observations.
So you only know, or you have a guesstimate of its size. We think it's about 150 feet in diameter, but it could be bigger or smaller.
It's conceivable that it could be somewhat larger or smaller. There aren't really any actual measurements of its size yet. Instead, what was done by Nick Moskovitz was to basically to get an estimate of its composition from what's known as visible near-infrared spectroscopy, and then from that to infer, based on what we've seen for previous objects with a similar composition, how big this one is likely to be. But the uncertainties could easily be several tens of %.
All right, well, we'll be looking forward to your data, and you'll be heading out to Goldstone about 4 o'clock today, just a couple hours.
No, I'll be heading out in about an hour.
Oh, really?
Yeah,
okay.
The Goldstone observations started at 10 after 4, so I need to be out there,
before
that.
then.
Yeah.
Okay, well, we're looking forward to your data and your information. We'll know
All right,
a whole
thank
lot
you
more.
very much.
Okay, so we're just a few minutes away from the closest point that DA14 will be to the Earth, and we can bring you more images from Gingin, the observatory outside of Perth, Australia. And we're going to take a break just briefly. When we bring back Paul Chotis, our scientist with the Near Earth Object team here at JPL. We're back on this live image of the shot from Gingin, and we see it's a clear shot.
It's a beautiful night down there. Now, bear in mind, we can't see the actual craters or any of that in even the largest telescopes. All we're going to see is a point of light moving against the star background.
But it is indeed a really fast-moving object.
Yes, it's a real challenge for astronomers to track this. It's moving so quickly, and in fact, it's so close that you have to figure out where you are on the Earth to figure out to look, what direction to look, what constellation it would be in.
We have a diagram of yours that can actually show folks where it's coming from, and we can cut to it. This is a diagram that Paul made himself. Here it is.
Yes, so on this diagram you see the Earth as the green circle, and there's a line going through it which is the geosynchronous satellite ring. That is the ring of satellites that encircles the Earth, and we're looking at it edge on, which is essentially the equator. The asteroid now is passing from the bottom to the top, and there are little time tags indicating at what time it is at what point, and we're getting very close to the actual closest approach. So it is just below that satellite ring, and very soon it will pass within the ring, which is essentially the time of closest approach.
And folks are worried about that, worried about, is there any possibility that one of the satellites could be affected?
We have checked for that. We've cooperated with the U.S. Space Command in checking where all the satellites will be at the time, and there's no chance that this asteroid will run into a known satellite.
You're very comfortable with the orbit of this particular asteroid. You think that you have it down? You're pretty certain where it travels?
We've been observing this asteroid for almost a full year, which is a long time for a small object like this, and we know its asteroid orbit so accurately to within 100 miles or so that we can be confident of these things. The closest satellite will be much farther away, 10 times farther away than our uncertainty.
So it is on an orbit, which would mean that it could come back.
Yes, and in fact in that diagram, as you recall, you could see the effect of the Earth on the asteroid. There was a significant bending of its trajectory. So the asteroid orbit will change quite a bit after this close approach. Before this close approach, its period around the Sun was 366 days. And after this close approach, it will be 317 days. Its orbit actually will shrink a little, its orbit about the Sun.
So when will it come back, and where will it come back to?
Well, we'll project that into the future. It seems that it could make a close approach in the year 2046, but that it cannot hit. Its orbit is known so accurately that we can project actually through most of the 21st century. And right now we're looking at the possibility, a very tiny possibility, that it could hit the Earth in the year 2080. I expect that will go away, and we'll know that we're safe from this asteroid for a long time.
And how will you use the information that Lance was talking about, the information that the radar can give us?
Lance's information is very helpful in computing the orbit. We will have essentially nailed the orbit of this to, it'll be one of the best in our catalog. It's that accurate.
All right. We are 50 seconds away, 49. The clock is counting down, and at that point, in just a few seconds, that is the closest point that DA14 will be to our planet.
To our planet in centuries, probably, as far as we know. So it's a remarkable moment as it passes by, and then it will be headed out.
And watching the counter on the left, the distance to Earth.
Yes, it's going to go through about 17,200 some miles. That's as close as it will get, and then it will start heading out.
And that's at the point where folks in Europe and then finally North America, as it's heading out, is about the time that we'll be able to see it.
Yes, it's going from the far south. Now it's over the equator, and it will be heading straight north and going essentially near the North Pole. So now we will have the polars in the sky, and we'll have a chance to see it from the northern hemisphere now.
All right. The counter is 0. It has passed closest approach, and this asteroid is going away.
It's on its way out.
It's been here, done that.
But throughout the day, it'll be observed by observatories around the world, and we'll get a lot of good information on its spectral type, chemical composition possibly, spectrum of it, and the radar data will give us essential information on the shape and size and the rotation.
What's very interesting is how much information you're getting from hobbyists, from amateurs. It's as though the more eyes are always better.
Yes, it's a worldwide effort, and astronomers around the world send in data on these asteroids, and they're all collected and all used in a combined solution to figure out its orbit.
All right, so what's next for NASA missions regarding asteroids?
Well, NASA has a planned mission to go to visit one of these near-Earth objects. That's the OSIRIS-REx mission.
We have some footage of it, in fact, that we can show folks. Now, this is a mission that actually will visit an asteroid.
It's going to go to a near-Earth asteroid, a little bit larger. This one is called 1999 RQ-36. Here you see the spacecraft approaching it. It's launched in 2016. It approaches it in the year 2019 approximately. It will reach out, take a sample. You saw a little puff of dust.
Yes.
It will put the sample into a return capsule and bring that back to the Earth, so we'll have actual samples of a near-Earth asteroid.
All right. Well, we're through. DA14 is on its way, but we will continue our observations of it, and we will be seeing it here in the United States pretty soon.
This evening.
And so that wraps things up here. We would like to thank all of the observatories that helped us out today. That's Southern Cross in Tasmania, Sanford Valley in inner Brisbane, Australia, of course the Gingin Observatory outside of Perth, Australia. And JPL will continue to push out these images of DA14 as it moves over towards Europe and then over to the Northern Hemisphere and the United States, North America. You can see these images on our Ustream channel. That is http://www.ustream.tv and then NASA JPL2. And then later on today, NASA's Marshall Space Flight Center in Huntsville, Alabama, they will also be streaming images from their telescope, and you can see those here in the United States from 6 p.m. to 9 p.m. Pacific time. That'll be 9 p.m. to midnight, and you can search for their feed at www.ustream.tv, and that will be NASA-MSFC. And finally, if you're interested in learning more about asteroids, there are 2 websites to check out. That's www.nasa.gov/asteroid-flyby altogether. And you can also follow us on Twitter, twitter.com/asteroidwatch. And you can get tweets all about asteroids. Oh, that wraps it up for us. Thank you so much for joining us. And again, many thanks for all the observatories that helped us out today. Take care.